I'd like to spend a few minutes and talk about what I refer to as the Foundation Trilogy, the three simple models that I believe are actually what's contained in all of the other models that one might choose to build, regardless of how complex or complicated it is. So we begin with what I call independent growth, where the flow into the accumulator is independent of what's actually in the accumulation of stuff and is dependent upon some flow rate into there. You might consider this to be something like, for a long period of time, the trucks taking stuff to the landfill is independent of how much stuff is in the landfill until it gets to a certain point. And it just depends on the character or the nature of what it is. But in this particular situation, the stuff accumulates based upon a flow rate. So if you look at it, depending upon the flow rate, the actual amount of stuff that accumulates, and here is the flow is very small, but it accumulates over time. And it might actually be a negative flow so that what's happening actually declines over time. You can then look at a structure, an exponential growth or reinforcing structure, where the flow is dependent upon the amount of stuff that's in the accumulator based upon some factor, which is typically less than 1. So that if we look at this and see how this develops, if we take the accumulation and we just say that it's 1, and then we take a growth factor of 0.7, you'll see an exponential growth curve where the amount added each time is increasing because it's based upon the amount of stuff that's in the accumulator itself. Now, this can also run in reverse, so that you might go in the opposite direction, so that it starts negative and it simply gets more negative. Or you can actually have a negative growth factor and it starts, and then the accumulation declines in the other direction. Well, no, it actually increases because it's a negative growth factor, so it actually increases. The third structure is a goal-seeking or balancing structure, where there's a current state and some goal, and the difference between them is responsible for some action to move the current state in the direction of the goal, and it's based upon some factor that defines how rapidly that moves. And if we take a look at this and scroll down to this part, and if we say that the goal is 100 and the seeking factor is like 0.1, you'll notice that here's the goal and here is what's actually in the current state, which is increasing over time. And the rate at which it changes is declining because the rate is dependent upon the difference between the current state and the desired state. And you can continue, in other words, if the seeking factor gets larger and larger, then it takes less and less time to go from the initial state to the desired state. Now, the annoying thing about this and lots of other structures is that they can have delays in them. In other words, if you look, the delay means that you take action, though between the result of your action and you realizing what that result was, there's a time delay. So if you do this, if you increase this slowly, you'll notice that we begin to get overshoot, so that here's the goal, but because of the action, the current state actually overshoots the goal, and you have to apply a negative effort to bring it back down to what the goal was. And if the time delay happens to increase, this situation continues to get worse. So now we're looking at a damped oscillation. You can get to a certain point where it's just a continuous oscillation, and it never actually settles on the goal. Or if the time frame is, the delay is long enough, you can actually get runaway oscillations where whatever it is that's experiencing this will destroy itself. And in response to this, there are one of two responses. You can either slow down the rate at which you change things so that it doesn't overshoot. Or you can figure out what the delay is and figure out how to reduce the delay. Now this is a simulation model done in Insight Maker, and you're welcome to come here and interact with this to your heart's content to get a better sense of the actual behavior of the different structures. You can simply do a simulation, and then you can change the variables. Note there's a graph for the independent flow, one for the reinforcing structure and one for the balancing structure. They're all running at the same time. You just have to depend on which one you want to look at. And there are variables for the independent flow, for the reinforcing structure, and for the goal-seeking structure. So it doesn't matter how complicated or complex the simulation model becomes. It's simply some combination of many of these three basic structures. And over the next few weeks, I will go ahead and rework and redo all of my simulations for all of the archetypes, where this is the reinforcing structure, and this is the goal-seeking structure, and all of the rest of the archetypes are outgrowths of them. And in this particular model, there is a video that describes that particular archetype and a link to an Insight Maker model that you can interact with that will give you a better sense of how that particular structure behaves. So they're all here, and the links will be in the notes section of the video. So see you in another video soon. Take care. Bye.